Okay, we're going to continue our discussion on similar triangles, and we're going to use them today to actually solve problems. So last class we looked at just determining how to define two triangles that are similar, and now if I've told you now the two triangles are similar, see if you can use it to solve problems. So hopefully you remember similar triangles, you need the corresponding angles to be equal, and you also need the corresponding sides to have the same ratio. So it says, in the similar triangles below, can you solve for the missing side x? So in this case, we already know that the triangles are similar. We can say that angle M is equal to angle B, angle O is equal to angle A, and angle N here is equal to angle C. So what about the corresponding sides? I think that's the part that we need to figure out first. So if I asked you MN, what does that correspond to on the other triangle? So it's hard for you to figure out. Look at the angle. See, this one has two dashes, and this is the one I created. What side also uses the two dashes and the one I created? The one I created is here. The two dashes are here. So yeah, it's this side. So MN actually matches up with BC. Okay. How about the side NO now? What does that match up with? So that's the angle over here, which is A, and there's the one I created. So yeah, NO actually matches up with CA. And then finally, MO, that'll be this side, that matches up with, I guess, AB. Now this is key. If you can see this right away, then the rest is pretty straightforward. But if you can't see this and you can't find the corresponding sides, then life can be miserable. So, knowing this, can you tell me which one or which pair of sides actually has both numbers that I can use to give me the scale factor? Yes, it's the blue one here. So 6 over 11. I'm just going to now write this as hello. MO over, what is it, AB equals 6 over 11. And I guess I'm looking for the one with X, so that's the green. So I guess MN over BC. MN is 4 and BC is X. And since I know in similar triangles the ratios are the same, I can now equate the two together and solve for X. If you want to write it down, I'll say since similar triangles have equal ratios of corresponding sides, then I can say the following, right? Then 6 over 11 equals to 4 over x. I will cross multiply to solve. X equals 11 times 4, which is 44. So x equals to 44 over 6, or that's just 22 over 3. Okay, and I don't have units here, so I'll just say units. Done. Okay. All right, number 2. Triangle MNO is similar to triangle MPR, and I want you to calculate the missing length of x. So once again, the hardest part here is to figure out which are the corresponding sides. I'll start with the big triangle. I'll start with, I guess, PR. PR probably matches up with, NO. That we can get. How about the next side? How about this PM? There's my 90-degree angle. And my 90-degree angle is over here too. Does that match up with the MO? Or does that match up with the MN? That's the question you have for yourself. Well, how can we figure this out? Well, I guess if I were to compare now, just sort of compare, look, this length and that one. It looks like the 11.4 is the longer of the two remaining sides, and that should correspond to the longer of the two remaining sides on this triangle. So therefore, it must be MN. So I'll say now PM connects with MN. And then finally, MR must relate to MO. Okay, so knowing this, I can find my ratio by looking at the PR and NO, because those are the two numbers I have. So 13.68 and 7.2. I'll equate that with the one that says X, so that means I want to make it equal to the ratio of 4 over X. Ugly decimals, but nonetheless the same idea. Let's cross multiply and solve. So 13.68 times X equals 4 times 7.2. That's equal to 28.8, I believe. This is not so nice. So I'm going to use my calculator. 28.8. Helpful if you turn it on. 28.8 divided by 13.68. And voila. I get about 2.105. So X is 2.105. Once again, I don't have units, so I'll just leave it as units. Okay? Alright, so my first two examples had separate triangles. Now, number 3, I've got what I call a nested triangle. A triangle within a triangle. So how do you find the corresponding sides? That might be a little challenging. Let me first of all label these. Let's call this A, B, C, and let's call this point here D. Let's call this point here E. Can you even see where there are two similar triangles? I hope you can see this one, yeah. I hope you can see this one, yeah. And they are similar because corresponding angles, right? This angle in both is the same. This angle here is a right angle, which is the same as this one. And the third angle in the triangle must be the same over there as well. So in this case, if you want me to write down the angles, I'll say angle A equals angle A. And I'll say here, angle B, which I think I should use 3 letters now. Angle ABC. So I'm talking about this one right here now. That is equal to angle ADE, which is up here. You see now we're using 3 letters to represent the angles because it's much more descriptive. I can also say now the right angle down here, that's angle ACB, that equals angle AED. So those are my corresponding angles that are equal. And so now what about my corresponding sides? Well, I'll say AB in my smaller triangle is corresponding to AB. I'll say AC in my smaller triangle corresponds to AE. And finally, I'll say BC, like my height, is corresponding to DE, the height of the tree. So, if this is too hard for you to see, perhaps you want to draw out the two triangles. You're more than welcome to do that. You can go A, B, C, and label everything this, 2 and 3. And then draw a bigger, similar triangle, ADE, and label that 30. That's perfectly fine. If that's how you can see it and make it better for yourself, please do. But what am I trying to do here? I'm trying to find the actual height of the tree, which is this height here, which I call DE. And that matches up with BC. That's what you said here. So I can write the ratio of H over 2. What other ones can I use to help me find the scale factor or the ratio? Well, I know there is AE, and that matches up with AC. So this must equal to 30 over 3. We can once again cross multiply. 3h equals 2 times 30, which is 60. We'll divide both sides by 3, so h equals 20. So therefore the tree must be 20 meters high. That's pretty tall. Okay. All right. Number 4 on the next page. Whoa, another nested triangle. Okay. And I've told you that ABC, so the larger one, and I'll draw this out. ABC, right? ABC, that's 12. The length of AC would be 10 and 5, which would be 15. And the length of CB would be 6 plus X. Okay? That is similar to DEC, the smaller one, DEC, which we have 5, 6, and Y. So once again, what are the corresponding sides? And if you said AC corresponds with DC, I'm happy. If you said AB corresponds with DE, I'm also happy. And if you said CB corresponds to CE, I am very, very happy. So now knowing this information, which one of these ratios gives me the actual numbers in both triangles? That would be this one right here. So I'm going to use that AC, which is 15, DC, which is 5, to be my ratio. And let's go ahead and solve for the rest. I'll solve for Y first, because I just see that Y and 12 are nicely done here. So 12 over Y. Cross multiply, 15Y equals 5 times 12, which is 60. We'll divide both sides by 15, so Y equals to 4. Ding, ding, ding. Do the same thing to figure out the X. In this case, 15 over 5 is equal to, this one's a little bit more peculiar, it's actually 6 plus X over 6. So if we were to cross multiply, we can still do this. 15 times 6, that's 90. But now we have 5 brackets 6 plus X. Yes, remember our discussion on polynomials? Yeah, we got to distribute this. So 5 times 6 is 30. 5 times X is 5X. That equals to 90. Got to do some algebra here. We'll subtract 30 off of both sides. That's 60 equals to 5X. We'll divide both sides by 5. So X equals 12. And if you got these answers, I'm very, very happy. Alright, let's try example number 5, and then we'll do 6 and they'll be done. See if you can draw a picture of what's going on here, okay? A person who stands 180 centimeters tall casts a shadow that's 45 long. So here's 180, and he has a shadow that is 45 centimeters long on the ground. A nearby telephone pole casts a shadow 300 centimeters long. So same thing, the pole's like here, woo, but the shadow is now 300 centimeters long. And the question is, what is the height of the pole? So I don't know if you can actually see the triangle, but and then well, we can compare the sides once again. The H, or the height of the pole, compares with the 180, and then the length of the shadow, which would be 300, compares with the 45. Now, some of you might have written down the other way, 180 divided by H is equal to 45 over 300. That's perfectly fine as well. But once again, once you have the ratio, cross multiply to solve. Well, big numbers. 180 times 300, that's 54,000. Gotta divide both sides by 45. 54,000 divided by 45 gives us 1,200 centimeters, or I'll say 12 meters tall. That's a pretty tall lamppost. Alright, one more for today. I will hopefully just set this up for you and let you try to solve this on your own. It says a 6-meter ladder is resting against the wall. So here's my ladder. It's 6 meters long. The first rung of the ladder is 30 centimeters. 6 meters, centimeters. I'm going to change this really quickly to 600 centimeters so that we're all in the same units. The first rung of the ladder is 30 centimeters from the bottom of the ladder. So this distance here is 30 centimeters. And it's 24 centimeters vertically above the ground. So if I were to go from the first rung of the ladder and just draw a vertical, this is 24 centimeters. How high up the wall does the ladder reach? So I'm asking you this. How high, what's the height of the ladder? If this, of course, here is the ground. So once again, I'm hoping you can find the two similar triangles and then go ahead yourself to set up the ratios and solve. So once again, I'm going to leave this for you to try. I'm going to be quiet. You try it out, then come back, check my answer. If we're right, we're all good, and you're set to do some work in class. Go for it. Once again, this is just my way of doing it. Your ratio could be a little bit different. That's quite all right. Yay, thumbs up. If so, you're good.